All right, folks. So, um, hopefully, first day went okay. Um, Second day here, a little bit of word problem action on Thursday. So, I'm going to go over the problems on the back of your worksheet. You'll do the ones on the front, and you can do those on the piece of paper that's attached. I figured there wasn't much room. If you look, hold on a second. If you look, not a lot of room. So, hopefully, that piece of paper will give you an idea of what to do. And there are some steps here. It says 4-step method, define your variables, write the system, and then obviously the rest of it, once we get the system, is a lot like the videos from yesterday. So let's read the problem here. All right. And so let's follow those steps. Tickets to a movie cost $11 for adults, $7 for students. I mean, right there's some info. Maybe we should underline that. It's money. And so obviously we know this is going to be systems. Now we'll have to work on how to identify a problem that involves systems when we don't know. But for now we know it's systems. And so we're going to have two equations. And I'm going to tell you right now, typically when you create those equations, you're going to have all of your information related to, for example, money in one equation. And then you'll have your information for something else. We'll find it in another equation. So got some money information there. Adults $11, 7 students, $11 for a movie ticket. It's probably pretty accurate. Let's keep reading. A group of friends purchased 8 tickets for $76. Now, 8 tickets, that's a number of tickets. That's not money. So keep that in mind for $76. It says write a system to represent the situation. How many adult tickets and student tickets were purchased. So step 1, or I guess it's, what does it say? Step 1, right? It's 4-step method. Define the variables. So basically, what don't we know? And look, on the back it uses X and Y. I'm not going to do that. I'm going to I'm going to use a variable that helps us to remember. So at the end, we're not confused. Like what means what? You can certainly use X and Y. That's fine. But I'm going to use A and S. And the way I'm getting that is, the question here is how many tickets, adult tickets and student tickets, were purchased. So anytime you need to find the variables, look at the unknowns, right? We don't know the number of adult tickets. We don't know the number of student tickets. So I'm going to use A to represent the number of adult tickets. And I'm going to use S for the number of student tickets. All right. And so that last sentence, and I'm going to have to erase this because I'm going to run out of room. But number of adult tickets, number of students. You should really do that first. Look for the variables, and we want to find two things. And, if you create one equation with two variables, you're not going to be able to solve it. That's why we need two equations, two variables, as well as the fact that our information ends up in two kind of camps. And that is money, and that is number of tickets. So maybe let's start with number of tickets. We only have one piece of information for number of tickets, and that is 8 tickets were sold. So what are those tickets made up of? It says a group of friends purchased 8 tickets. That group of 8 could be all adults, all students, could be some adults, some students. In the end, we don't know how many though, right? So it's going to be, so our system is going to be not system. One of our equations is going to be A plus S equals 8. So this is kind of what I would call hidden information. Sometimes equations will have that. They'll kind of have like a hidden piece of info. And it's not really hidden, but you're like, well, what other information should I put in the equation with 8 tickets? I guess find the total 8 tickets and think about what makes up that 8 tickets, right? It's number of tickets, some adults, some students, some combo. We don't know how many. 8. Okay. And then for the amount of money, so we had created one equation for number of tickets, right? And I'm going to have trouble writing this here, but number of tickets. That was bad. And then we create another equation, and that's going to be all of your money info. Now, this isn't going to always happen, but it happens a lot with systems. You can almost organize your info into two equations. Everything else is money, and our total is $76. What is that made up of? Well, it's made up of adult tickets and student tickets. And if we sold, 10 adult tickets, that'd be $11 each would multiply. So $11 times the number of adult tickets. And then we would add that to $7 per student tickets. Again, if there's 10 students, that would be $70. You would take 7 times 10 and you'd add everything up, and the total is going to be 76. And so, so one equation is the number of tickets. The other one is really everything related to how much money was spent, money spent. And all of the info is on money. Everything, is money related goes in that equation, because think about it. If it's an equation, both sides need to equal, like be balanced. And if this is money on this side would have to be money as well. So you have to get those other numbers in there. Okay. Now, I'm going to clear the screen. And so you can go back and pause it if you need those to kind of follow along. But we had A plus S equals 8. And 11A plus 7S equals 76, right? So there you go. That's your system. Now you can decide how to solve it. This could really go either way. If you want to do substitution, you would basically just get one of these variables by itself, probably, right? The A or the S, it doesn't really matter. You just move one over, make it negative, and you could do substitution. Certainly, you could do that. You can also do elimination. I mean, it's all lined up for it, right? You would just have to, look at the A. You can make this negative 11, and you could multiply everything times negative 11 to get rid of the A. I mean, heck, you could even focus on the S if that's what you want to do, and multiply times negative 7. Either way, everything's positive in both columns, all lined up. So you do have to multiply times a negative, and you have to get it so that it's the same. So I'm thinking, why don't we just do it the way I have it right now? Distribute, and you're going to have two new equations. So I'm going to just kind of bounce over here, and right time would be negative 7a minus 7s equals negative 56. And then 11a, I guess I should probably make that the same color. 11a plus 7s equals 76. And you're ready for elimination. Right here is where your elimination is going to take place, right? This is going to cancel. When we add negative 7 and positive 7. So what do we got here? We got 4a equals, and I guess that's 20. Divide by 4, so a equals 20. Now 20 what? That's why I have the a there. It's the adult tickets, and it's the number of adult tickets. And so you would obviously not have erased, but right here I said a equals, the number of adult tickets. We had that info. So it's, please make sure you label that. A is the 20 adult tickets. Oh, 4. Wait, 5. What am I doing? Oh, wait. Sorry, folks. What the heck am I doing? How about I actually remember to divide, right? 20 divided by 4 is 5. That's fantastic. A equals 5 adult tickets. All right. So, again, go back and pause if you need that. Apologies for erasing that. But then when you look at your equations, well, if we sold 8 tickets total and 5 of them were adults, that means it's got to be 3. So you could solve, you'd minus 5 from both sides, and then there would have to be 3 student tickets. All right. Hope that helped.